There we go. All right. So the first thing that we think about is numbers weren't always there, but they were discovered, not invented. And so think about the first very basic need of numbers. It was during the bartering and trading days, right? And so you had caveman who was really good at foraging and growing crops and stuff like that, and you had caveman that was really good at shooting buffalo. And so one caveman said, I'll trade you buffalo for corn. So that's a barter, but they had to decide how much corn was a piece of buffalo worth. So it was 1, 2, 3, 2 pieces of buffalo for 2 shucks of corn or whatever. And so therefore, these are all what we call counting numbers or natural numbers. Natural numbers are just counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is our most basic set of numbers. Well then, caveman found out what the Great Depression was. And so instead of it just being 1, 2, 3, 4, 5, caveman said, I ain't got nothing to trade with you. How do we represent nothing? 0. Well, 0 wasn't included in the original set of numbers. So we had to include 0, and that's how we got whole numbers. So now we can have a bankrupt caveman. Kind of reminds me of that, I think Louis Armstrong sings, I ain't got nobody. That old jazz song, right? So that's where the whole numbers come from. Okay, so after whole numbers, then caveman discovered he's bartered, he's prospered. Then he didn't have anything, so we had to incorporate 0. And then caveman discovered debt. Negative numbers, absolutely. I didn't get a buffalo today, but I still need your corn. I will pay you 2 buffalo tomorrow plus 1 buffalo in interest if you'll give me your corn today. So therefore, he owes him 3 pieces of buffalo. If you owe something, it's a negative, right? So we come up here with caveman and we get integers. And that's where the whole concept of debt came from. That's how we can account for debt.
Is this like literal or?
I'm telling you, basically, how I think it worked. Okay. That's a Z for integers. It's a Z for natural numbers. It's an N for whole numbers. W. Now we're going to get cute.
We're already cute.
Absolutely, 100%. Now caveman says, I don't want to pay you a whole piece of buffalo for interest. Will you take a half?
Fraction.
Yes, otherwise known as what kind of numbers? Rational, because we can write it in a ratio. So here comes the rational numbers. Those are Q. Rational is Q. And so therefore, now we can pay our debts in cents as much as we can in whole numbers. I know with the corn shortage, a lot of people say round your change up, you know. Saw it in Chattanooga probably the most. Do you want to round your change up to the Boys and Girls Club because there was this coin shortage during COVID. So they wanted to do away with those rational numbers, right? They wanted to keep your rationals. And so that's your change, your fractions. All of these are part of the real number system. All of these are part of the real number system.
Miss Harrison, did you see where in Saga that got turned around that woman off the road?
That guy tried to run too.
Yesterday, there was a guy in Saga that this woman was leaving the gas station and he followed her and tried to run her off the road, and he got in front of her and stopped and got out of his car and like left his hand behind his back, and the woman had to go in the grass and like zoom off.
No, what you do is you swerve the other direction and hit him.
And she, yeah, true. Then she go to jail, probably. Yeah. But she called the cops and they said that it was more likely sex trafficking. Okay.
Oh,
It
that's
was
scary.
just in Saga.
I would have hit him.
I made
The
two
boys
guys
was up
walk me
high,
out to my car last night for work because I was terrified.
I don't blame you. That is,
I'm bringing the blazer without a license and just speed bump.
Do we hit it properly with back up real quick?
Yeah.
that's
double tap.
very scary. Where'd you see that, Macy?
What?
Where'd you see that?
It's all over Facebook.
No,
People are
tinker
sharing it.
posted it over.
That's very scary. So now we're looking at, that sounds like an extremely irrational person.
Oh gosh. Rational number.
Yes. Irrational numbers. Irrational numbers. And we denote irrational numbers with, imagine that, a capital I.
That person's very irritating.
Very irrational person.
How do I say capital Y?
I. All of these numbers are part of the real number system. And inside or outside the real number system is the entire number system, which is complex. Do you agree?
Yeah.
Very complex, right?
You got circles in there.
And Krista beat me to the point. In this last little circle, imaginary, which we denote with a little I.
So for real?
So we started out with cavemen. We advanced through our whole numbers, integers, rationals, real, irrational person at Sligo Road. We live in a very complex world, and sometimes we even have imaginary numbers.
Does real have a rotation?
Real has an R. Thanks, Isaac.
And a J for imaginary?
A little bitty I.
That's a backwards J.
A little bitty I. So with that being said, let's look at the square root of negative 64. 8 what? So where does that fall?
Complex for imaginary.
Yes, complex.
CI. Why would it be -8? Oh, wait.
So it actually plus or minus, right?
I do need to draw that squiggly.
That's a semicolon.
You need to go back to English. Hey, at least it's like not grade English, not first grade. So why is there a C and an I?
It's complex and imaginary.
So complex and imaginary. What about 10I times a negative 2I?
That's negative 12I. Nope, just kidding. 29.
Makes me point out square.
It'd be 20.
20.
Yeah, then
I just multiply. Oh, I didn't see the times. You know, you said times. Oh, I didn't see times either. I was thinking.
Yeah, that little bitty dot.
what's natural and real and natural?
So it is,
Whole.
it's natural, it's whole,
R.
it's an integer,
It's rational. It's real.
it's rational, real. Oops. I always want to make rational and real the same. Rational
So when you take all
Real.
those, if we don't put these,
and complex. Doesn't have to be in order.
yeah, but if we don't put these letters in R, you can take off points.
Especially if your instructions say classify.
Yeah, sure. What if we wrote acronyms? We can't read the letters.
That's fine.
Why is that with complex?
What is it, Krista? Q is rational. I don't know who decided rational was Q. The only thing I can think about is quotient, maybe.
Yeah,
Natural income first. It's all of these.
What is I? That's imaginary. That's actually.
Integer is Z.
Thank you. See, y'all have to keep me honest.
Why is it complex?
Complex because it's the whole, complex is the whole world.
So everything is complex?
Yes.
We're all complex. So even if they're
Individuals.
just natural numbers.
Yes. Everything's complex. You can pretty much put C down for everything and you'll still get it. All right, so how do we simplify 1/9 square root of? Square root of 1/9. Okay, so Krista says plus or minus 1/3. Is it a natural number?
Yes.
Natural numbers are counting numbers. Is it a whole number? Is it an integer? Is it a rational number?
Yes. You.
Yes.
You are C.
Yes. What is 1 divided by 1/3? I mean, 1 divided by 3.
That's a rational.
It's a rational number because what is our test for irrational?
It's not repeating.
Terminate.
Are we gonna be able to use
Terminating, not repeating.
Non-repeating, non-terminating. Okay, so because this equals in a decimal form, it's non-terminating, but it repeats. So it's rational, not irrational.
Does it have to be irrational? Or can it be rational and irrational?
No.
Just
They are mutually exclusive, meaning you can only be one or the other. You can't be both. Krista.
Because I'm trying to feel like it's irrational. The fractions, integers, or and the whole base equals 0. It has a 0 forward with it. So what is like for irrational?
Irrational is numbers that are non-terminating, non-repeating. Pi is an irrational number. Non-terminating, non-repeating. What is number 4?
After you there, then again, 6 plus 5i.
6 minus 5i. So it is a complex number.
So how do we get 6 minus 5i?
So you have, we're going to take the first parentheses, 15 minus 8i, distribute the negative. So -1 times +9 is -1 times a -3i. Combine like terms. 15 minus 9. And then -8 plus 3. Yes. So it has a real piece and it has an imaginary piece, but it's one expression. And so like Isaac said, the only thing you can classify it as is complex
You can't even put imaginary.
because it's got a real piece too.
That is imaginary.
Yeah, but the 6 makes it as 6 is back.
No, she put an eye, is what I'm saying.
That's my goal.
Oh.
I think we're just gonna go with this.
Today.
Let's call Miss Ballback. All right, number 5, foil it out. First,
36.
outer,
29.
inner,
Negative 9.
and last.
Negative 5.
Combine like terms.
36. 49. Minus 5. Plus 5. Actually, we're gonna do that.
Okay, I'll go ahead and do it. So now combine like terms again.
36 plus 5 is 41. Plus minus 1.
And what type of number is this?
C.
Now you have out of the 41. How do we figure out
You count.
divide?
41 by
41 divided by 4.
Wait, by 4. Because there's 4 spaces,
So it's 10 and 1/4.
they don't make no sense.
Which means there's 4, there's like a -1, a +1.
So it'd be square root.
1, yeah.
So that would just be I.
That is CI.
Yep, so that is CI.
This looks like some sort of code.
I know.
I don't like it.
So what was your question, Krista?
What the answer was, but is that just I?
So because anytime you're looking at I, we had I to the 41. Think of it like a baseball field.
No, I mean, I understand why you have to divide and whatever it lands on. Like, that's what it is, but I didn't see the I, so I'm trying to figure out where you put your answer. That's all.
The answer is I, and so it's CI is the classification.
Was it that the I or something? I know how to put it.
Okay, great. So whatever this is tells you whether it's out of the first, out of the second, out of the third, or out of the fourth.
Even if the answer is I, you still need to put I in classification. Because that's what was throwing me off. The answer is just I, and you still put I in the classification.
Yes.
They're written differently,
All you got is 10. They figure out 10 times through completely, and then, you know.
So we go back and we say,
Big brain.
so our cycle is I to the first, I to the second, I to the third, I to the fourth. When we take 41 and divide it by 4, it's gone through this cycle 10 times.
I think I like this better way. This, this way better than counting 41 times.
I tried to convince y'all. So this is I.
It's better way.
This is -1. This is negative square root -1. And this is 1, right?
Yeah.
So it's gone through this cycle 1, 2, 3, 4, 10 times. And then we have 1 extra left over. So at 40, we're right here. And then we go back to 1.
Makes you got it.
It's whatever you're left over here is where you land. Because then it would be 2, 3, and then 4 again. Okay?
I'm just gonna pretend I know what you're talking about.
So the other way you could do it is you go through 10 times.
Yes, there was what 10 times is what I said.
1, 2,
This
3, 4, 5,
cycle.
6, 7, 8, 9, 10.
So 1, 2, 3, 4, 5, 6, 7, 8, 9.
1, 2, 3, 4, and then 1, 2, 3, 4. It's the cycle that repeats over and over.
1, 2, 3, 4, 5, 6, 7, 8,
9, 10, 11, 12.
11, 12, 13, 16, 17, 18, 19, 20.
So it would be 41. So it's out of the brush. Okay? What about this one?
I don't know.
Oh, actually.
Nope.
172 is -16. That's negative, and then -16I to the third.
Take 5 and do 7 through 10.
I said you don't find it.
Make 5 and do 7. Oh, we did 10 for another.
Yes, I think this way. Okay, yeah, I think I got it. It's 14.
Other than the first one.
Okay, do I have volunteers to present?
I'll present number 8.
I can do number 9.
All right. Everybody say 10 at once.
So. Awesome. McKenna.
Can you just write them on our whiteboards?
Yes, ma'am. Macy. Ellie, you want number 10?
So this number is going to be
Hopefully we can, but if not, it's going to take you 10. Yeah.
All right, Mr. Isaac, are you ready?
So
You have the floor.
it was two squares, so I should look at the negative side.
Okay, number 7, is negative 2i cubed times I to the square root of 7 squared. Negative 2i cubed equals negative 8i cubed, which I cubed is equal to negative square root of negative 1. So when you plug in the 8, you get a positive 8, which leaves the square root of negative 1, which is just I. So and the I square root of 7 squared basically just leaves 7. It's the 7 out from underneath the square root, which is 7 I squared, which is just negative 7. That leaves you with negative 7 plus 8i, which when the multiplication will just be complex. Yeah.
On the first part of it says equal negative what?
This part here,
Yes.
negative 8i cubed.
And how do you do that?
Times this by 2i 3 different times.
So it was equal positive I. Wow. Is that right?
So it's I times I times I.
Right, which is negative square root of negative 1.
Probably just broke it
So we
down.
add equal to positive 8i, so we add. And then your second line, the last thing says -2.
Yeah, that after you do this right here, that leaves you with 7i squared, and I squared is just -1. So,
So you just broke down like the cubed and the squared.
Yes.
And okay, good.
So
Thanks,
we're
thanks.
actually multiplying 7 and 8i. Yeah, I'm just.
Ooh, T?
Because I don't know.
Two
Like
babies?
2 times 5.
So Isaac, on that final step, did you add or multiply?
don't they just go together if you do it? Is it not the same type factor?
Let me see.
Okay, I missed what I was saying there. I forgot to multiply.
So you have 8i cubed, right?
No, there's 8i.
Just 8i.
Yeah, at the end, it's just 8i.
Yeah, 8i and -7. That would have been -56i.
Oh, okay.
So. Oh.
Going to number, Macy, will you present number 8 and I'll come back to number 7?
Yes.
Okay. I present to you, Emma Hurd, number 8. Alright, can't see my board. So yeah, 3 minus 5i and 3 plus 5i. He's gonna get on the camera so I can see your face. And you multiply 3 and 3 and you get 9. And then you, okay, whatever, you just pull it out and then you get plus 15i minus 15i minus 25i squared. This right here cancels out. And then you're left with 9 minus 25i squared. And then you cancel that stuff out and you get 9 plus 25, which is 34. What's the plus? What? Oh my gosh, I don't freaking know. It's a whole real.
Integer, rational, real, and complex.
Yeah. Good job.
All right.
No! Okay. I had number 9, and it was I to the 16th. You take 16 and divide it by 4, which equals 4, and I put my little groups over here. So if you count 4, 1, 2, 3, 4, it's 1. So 1/6 or I/16 equals 1, and which is a natural number, a whole number, a integer, a rational, a real, and a complex. Question. So I got the 16 over 4. I figured out that part. How do you get the -1 and then the positive?
She was just listing out her cycle. We're gonna come back to number 7. We're gonna
I
come back.
got conflict.
That's what I was thinking. I was just
Ooh, I was
trying to
because it can't be anything else because it has not.
yeah. Okay, so I had number 10, which was the square root of 150. So I got my 2 factors, and that was 25 and 6. 25 is a perfect square, and its perfect square is 5. And then just 6, goes down here. So my answer was plus or minus 5 times the square root of 6. So this would be complex, real, and then irrational.
You have some really good name.
It makes me want to cry.
So are there any disagreements?
Nope.
Let's look at
Number 7.
number 7 together. So number 7 says -2 I to the 3rd power times I to the square root times the square root of 7 squared. Okay? So, and Isaac told us, if you break it apart, you've got negative 2I times negative 2I times negative 2I. That does simplify. I cubed, right? I'm not going to plug there. I'm going to hold that. Now I'm going to come up here and look, and I have I square root of 7 times I square root of 7.
Positive I squared.
But what about this? I agree with the I squared, but what about this 7?
Oh, no.
It drops, you just lose, it drops the square root.
Correct. Yeah.
So you just lose the radical. Because anytime you square a radical, or square a square root, then the radical is the only thing that disappears. So now we have 7 times I squared. Right? So if you multiply 7 and negative 8, you get negative 56. I to the 5th. Bless you. I to the 5th, if you say 5 divided by 4, that's 1 1/4. So this equals negative 56.
See, so
Either way,
how did you get 5 and 4? What did 5 and 4 look like?
when you multiply
Uh-huh.
i's, you add the exponent. So that gives you 5. And to find out where you land on the cycle,
Oh. Yeah, I see.
it's whatever this is. So negative 56i.
And then to get the 1 and 1/4. Oh, yeah. Okay.
This exponent divided by the 4 because there's 4 numbers in the cycle. Okay, and so this is imaginary and complex. So either way you did it, whether it was my way or Isaac's way, you still came up with negative 56. Any questions? All right. So now let's look at the properties. Now let's look at the properties. So the commutative property of addition. I always think about my commute. So when I drove back and forth to UTC for 13 years, I went straight up the interstate from Mentone, straight back to interstate, back to Mentone, right? And what was really cool about working in Eastern Time and living in Central Time is at UTC, when I would leave at 5 o'clock Eastern Time, I'd get home at 5 o'clock Central Time. So either way, it was the same thing. That's what the commutative property of addition is. It says that 3 plus 4i is equal to 4i plus 3. Either way, it's the same thing. Backwards and forwards, all the same. The associative property of multiplication just means, think about your groups of friends, who you associate with. So maybe today one of your friends is leaving you out. So you're this number 2 on the outside. However, Tomorrow, when you're all buddy-buddy again, 2 and 3 go together. And 4 and 5 are still that complex situation. But if you multiply them out, then they're all the same. So in this case, this little 3 people block 2 out, but they're still friends, kinda. Tomorrow, 2 and 3 are together, 4 and 5I are together. But when you multiply them all out, they're still the same. Distributive property says that 5 times 6 minus 7I, once you distribute this 5 into each, you have 30 minus 35I. Those two things are equal. The identity property of multiplication says 7I times 1. Basically, it's anything times 1 is equal to itself. Even when you multiply by 1, it doesn't lose its identity. And then finally, the inverse property of multiplication says that 3 plus 8I plus its opposite is equal to 0. So if we look at number 16, this simply says 2I times everything in the parentheses is equal to 2I times 7 minus 2I times 5I. What property are we seeing there? Distributive, because we're just distributing. Absolutely. This one says 1 divided by 3I times 3I equals 1.
Associated property of multiplication.
Okay, so I hear 2.
No, I didn't. It's not.
It's the inverse property, because what is the inverse of 3 over 1? 1 over 3. So this is the inverse.
So even though it says it's the inverse of addition.
Yeah, this is actually inverse property of multiplication. Exactly.
Next one.
All right, so the next one this is talking about how your friends are grouped every day, right?
Associated.
So yes, associative. Now this one says that negative 12 plus I plus 0 still equals negative 12 plus I. So that means you did not change your identity. On this one, 6I times 2I comes first, then we multiply by 8, and then we're going to flip it. 8I comes first, minus 6I times 2I. Commutative, that's that commute.
all this stuff be on the quiz tomorrow?
This one says that when you add the opposite, they equal 0. So what is that?
Inverse.
Inverse. And this one is of addition, whereas the one that we saw previously was multiplication. So now, if we're looking to add the additive identity of 6i, so identity means your identity doesn't change. So what can we add to 6i that won't change its identity? So that's the additive. What can we multiply by 6i that we won't change its identity? So we don't want to change its identity. So now we want the inverse. What do we need to add? When we do the inverse, we want it to equal to 0.
Plus 8 plus 3i.
Exactly. Then the multiplicative inverse, so this is the same thing as -8, -3i over 1.
So then we do 1 over -8 plus 3i.
-8 minus 3i, so it's 1 over itself. And that's going to equal 1. Because with the additive, you want it to equal 0. With the multiplicative, you want it to equal 1. If you did a plus, then it wouldn't directly cancel out. All right, and then finally, we will look at this concept of called closed. So the concept of closed means that in the set of complex numbers, for example, if we had 4 plus 3i plus 2 plus 5i, what would our result be? The concept of closure, in addition, means that what set does this belong to? Whole number, integer,
C,
complex. And what does this belong to? When you say take a complex number and add a complex number, is your result still a complex number? Then this is closed. Anytime you take two numbers from a specific set and add them together, and they produce a number from the same set, then it's closed. If they don't, then we call that open. closed under division, if we have 8i to the 4th divided by 6i to the 3rd, we would have 4/3 I. Is that still a complex number? So it's closed under division as well. I'm always hesitant with this all. Anytime that I see all, my bells and whistles go on. It is false because,
Every number is complex number.
yes, and is this a complex number? Yes. Is it a pure imaginary number?
No.
No. Think about your diagram.
True.
I say false.
So irrational, complex is the entire system. Is irrational in the system?
Yes.
Yes. So a number can be irrational and complex. And then finally, the product of a real number and a complex number is a real number. Yeah, 4 times 4i. That's not a real number. So that's false as well. All right, so here you go. We only have a few more pieces to finish this unit. You have completing the square, which we've already done a lot of.
What's
Completing- That's when we were going from standard form to reference form.
Oh,
So we've already done a lot of that. And we're gonna finish it up next week. We're also gonna finish up quadratic formula next week. And so we will have our unit test next week.
Next Friday.
Probably earlier than next Friday. I'm thinking like,
Do we have to
but that's okay, I don't wanna write it all week.
I'm thinking like Thursday. Is what I'm thinking. Wednesday or Thursday.
Then can we have a huge spring break on Friday?
Yes. Yes.
We are only 31. We have 6 units. to
Okay,
go.
that's okay.
We are hard workers.
Do we have a standardized test?
You don't have any ERC.
Do we have a midterm in here?
You don't have any ERC.
Thank goodness.
Yeah, they read my science too, and I'm so, woo.
Yeah, US history originally didn't have one, then they grew one on US history.
Good thing I built
Oh,
it.
All right, Miss Emma, do you have any questions?
So.
No, I'm only on module.
Miss Emma,
Can you hear me?
I can now. Do you have any questions?
I'm on 3.
No, I don't.